all acquainted with the Zoom platform, we ask that you please mute yourself on entry and feel free to participate in the instruction by either under participant selecting raise hand to ask a question or comment during the discussion, or just add comments and questions through the chat function in the Zoom platform. Quick introduction of our instructor today, Terry Nordby. Terry Nordby of Air Sealing Solutions. He's been a general building contractor for over 40 years. In 2009, he assembled California's second passive house, Retrofit. In 2012, he built California's first new construction passive house. He now consults for architects, designers, contractors, and builders on how to achieve high-performance buildings with ZNE targets. He has been a writer for Home Energy Magazine and Journal of Light Construction. And keep your eyes peeled for a book he will soon be releasing on air sealing wood and timber frame buildings. Welcome, Terry. I welcome you to share your screen and take it from there.
Glad to be here. That sounds a little brokey-uppy. Can we move on to the slides, Ian?
Yeah, you're welcome to share your screen.
Okay. All right. So I just want to welcome anybody who's come back from the last session. If you missed the last session, it may be a little missing links into this session. If you missed the last session, please come back. This is pretty valuable information for the future of building better buildings. Air sealing is an essential part of that. I think the first session was a lot of theory on why air sealing and the physics of air sealing. This one will be a little bit more nuts and bolts and about makeup air. When we make tight buildings, we need to be able to breathe in them, and that's no longer a problem. So I guess we'll just jump into this. I'm going to actually backtrack a little bit from where we left off. Excuse me. This slide I passed on the first run, and I put it back in for this run. And the significance of this slide is to sort of emphasize how air sealing is really not, it's kind of a freshly known in the building world. 20 years ago, air sealing didn't exist. Suddenly now, air sealing is front and center. It's real important, and people are scrambling around trying to figure out how to air seal buildings, what it means, and there's really very little knowledge out there on what air sealing is, why you do it, and good materials for it. So these numbers here, the percentages of my field experience. I've been working with people on air sealing for the last, let's say, 12 years, and this is my takeaway from walking away from jobs, and the reason that jobs fail. The primary reason jobs fail is because there's really not a lot of knowledge around about how to air seal. So 95% of the first blower door tests, for those of you who missed blower door, we won't do that this time, but it's a way to test buildings for leakage. 95% of the jobs I went to, they did not pass the desired leakage number on the first round. That's not necessarily a big deal, but it's pretty common. 85% of the builders, contractors, have never attempted a super airtight building. You know, we're not used to that. It's very, very new. In the passive house world, this is just what you do. It's not an option. It's what you do, and it's what you have to do. It's a requirement to have a super airtight building. So when I work with passive house people in buildings, the successes are usually much higher, and the understanding of air sealing is much deeper and greater. 85% of the time, some of the air sealing opportunities were missed or left out. So I show up and they've got advanced too far into the assembly and covered up air sealing opportunities. Very, very common. Again, because there's not an understanding of when and where it's time to air seal. 85% of the time, there's no target leakage, ACH 50, except for passive house. So what does that mean? When people start building, the clients, the contractor, the architect doesn't say, we want this building to leak X amount of air. It's usually not, it's not even in the language yet. It will be. So I get prepared. This will be in the language, and we will have to learn how to do this. 80% of the time, sufficient air sealing details are not on the plans. That's more like 90%. 40 to 60% of the time, there was not a designated person in charge of the air sealing, which is one of the key factors for failure to achieve your numbers. There has to be a designated person on the job who's in charge of air sealing. And 85% of the time, I was called in too late to help to achieve better air sealing. So, it says at the bottom here, we need to get better at this. And that's why you're here, and that's why I'm here, to learn how to get better at air sealing on buildings. Okay, so now nuts and bolts, puddle sealing. I think I made up this term. I don't know if I made up the method, but it's something I use a lot, frequently in all of my jobs and consulting. And puddle sealing is basically immersing a group of wires. There's let's say 15 Romex wires coming up from the living space through an attic top plate, and you just build a bathtub around them, and you fill it up with something, and you surround all the wires, and they're all air sealed, rather than use foam. Again, if you missed the last time, I do not use foam ever, almost ever, as an air sealant. I use it as a plug, and then I put the air sealant on top of that. And I may explain that more. I will. So here's this really fast sheet. You're up in an attic. There's a lot of wires coming up, tons of holes. It will leak for sure. It won't leak maybe. It will leak for sure. So surround the wires with some scrap wood. Fill the bathtub up with plaster. I mixed it with fiberglass bats, just chunk it up in there so it gives it some body. And you pour it in, and pour it in, thus surrounding all these wires. And you've air sealed 15 wires for a long, long time, for fairly cheap. So here's more puddle sealing. So this is conduit. This is some offices I did. And there was, of course, a lot of conduit coming up through the floor, and a lot of cables, communication cables, electronic cables coming up through the floor. And how do you air seal 20 or 15 wires? Foam will absolutely not air seal 15 or 20 wires coming on. It'll do an okay job, but puddle sealing does an absolute bomb-proof job. So this conduit was plugged at the bottom with denim insulation stuffed, and then the top was puddle sealed with this product here that has a flow rate, kind of like honey at room temperature. It's unlike caulk. It has a flow rate, and it just sinks and puddles and lakes up around anything that's in the puddle. Here's what it looks like with a foam fill underneath, not denim, and then the puddle is on top, surrounding all these wires. So here's what I call planning ahead. Again, these are those offices, and if you're running new, you can set yourself up to air seal many multiple wires very easily by planning ahead. And basically, it's done by, this is the bottom plate. I asked the electrician, I said, what parts are there going to be a lot of wires coming up in the building? And he said, here. And so I said, this is what we're going to do. We're going to drill holes in the bottom plate. I actually have a prop here. I'll show you how this can work. So let's see. Oh, you know what? I need to get, hold on. I need to get my camera working. Okay. So I guess you can, I hope you can see that out there. So this represents a 2x6 bottom plate, right? And so what I had the electrician do was drill a hole through the bottom plate and stop at the subfloor. You can see the subfloor there, right? The hole just goes to the subfloor. Then I said, okay, now I want you to drill your wire holes through the subfloor. So the wire holes, whoops, come up. You run your wires through the subfloor. Hold on a sec. You run your wires up through the subfloor. Whoops, then over here. And then after then when you're all done, the wires go wherever they're going, to the boxes and whatever. And then you fill up these holes with this. In this case, it's filled up with elastomeric caulking. It's planning ahead. I mean, there's lots of ways to air seal wires, but if you plan ahead and do this, it's just an easy, bomb-proof way to air seal a lot of wires. So this is a form of puddle sealing. It can be in conduit, and I'll show you other forms of puddle sealing as well. This is the products for use for puddle sealing. Like I said, this ChemLink. ChemLink is an elastomeric, and it has a lower VOC. The one on the left here is Sikaflex, which you all use a lot. But they make these polymers that have a flow rate, like I said, of honey and room temperature. This right here shows a blob of this ChemLink was put on plywood, and then I held it vertically, and you can see how it runs down. So this rundown is the important gimmick, trick, and use of this particular kind of a sealant. It'll go into places where caulking won't go and where foam won't go. But so these are the products used in puddle sealing. There are other ones. So here is a retrofit job, and I had a blower door on. I was checking for leaks, and leaks were coming out between the plates. Leaks were coming out of hidden places I could not get to, right? So I drill a hole in here, and I hit down here. I'm injecting, flowing this self-leveling caulk into the holes, hoping that it would go down and eventually seal up the original leak. Now, it's possible that it won't. It's possible it can just flow out forever. But in this case, I lucked out and it stopped the leak. The tape here is just to keep the elastic from flowing out of the hole. So down here on the right, this picture is a picture of using puddle drill and flow sealing to seal unhidden leaks. Over here, these holes are sealed with elastomeric caulk, and up here, this hole is sealed with tape. So there's 3 different ways of air sealing this one particular situation. That's why it's good to familiarize yourself with the materials that can be used in air sealing, not just canned foam. Notice there's no foam used here. I like to tell my customers, we don't use toxic foam. We don't need to, and it's not as good and as durable as other air sealing methods. So here's more of puddle sealing. This is, again, is this stuff here, ChemLink and Sikaflex. Here's a remodel. Here's a bottom plate, and these holes went down to crawl space. All of these holes are going to crawl space. So what I did was I went to the holes and I stuffed them with denim insulation. I stuffed it down to the subfloor level, and then I filled the top up with this liquid elastomeric, and the denim was so it wouldn't flow out and just keep dumping into the crawl space. So again, when you puddle seal, you can completely surround a lot of wires, and you can fully seal them, and you can see the seal around. You jiggle the wires, and they're embedded in this gooey, sticky sealant forever. Here's another puddle seal. This hole was dammed up with denim, so the liquid wouldn't flow out. It's good stuff in your toolbox to know about another air sealing tool. Here's another method I call flooding. This product down here it's an elastomeric with granules in it, and multiple wires on the top plate. You can merely flood on the top, not in the hole. Actually, this did go into a hole, and air seal around a lot of wires. No VOC, non-toxic air sealing that surrounds the wires. You can see the air seal. You can see it. You can see it working. Use foam, you can't see it working. It looks like it works. Okay, planning ahead, puddle sealing. Here is here, step one, you take a piece of plywood, right, scrap, you screw it onto the 2x6 stud. The electrician drills holes. This is going horizontal. He drills holes, runs his wires through the holes. You take this piece of plywood, you pull it away from the 2x6 stud. It's just tacked on by 2 screws. Surround it with some, just fill it in the sides and the bottom with scrap wood, and you fill up that chamber with wires going through it with a liquid elastomeric. So here it is being filled up. Here it is filled up. And imagine these wires are coming from the conditioned space on the other side of this 2x6, going through, completely surrounded and embedded in the airtight elastomeric, and coming back out into the unconditioned garage. Here's what it looks like on the job installed. Here's the box that was made. And of course, this, if you did this with canned foam, you could do it in about less than a minute. But I wouldn't warranty that for lasting very long. This is a 60 to 80 year air sealing. The wires can jiggle all they want, and they will never break loose of the liquid bed. The real job, wires coming out into the garage and into the electrical panel. Unconditioned space, air can't get into the conditioned space. So all of this started some years ago, like 10 years ago. I was in New York City, and this friend of mine was trying to achieve a passive house air tightness standard on a 300-year-old brownstone house on the Upper West Side. And he said, "Come and look." And we're not doing too well here. It's leaking like crazy. And he said, "Tell me what you think." So one of the first things I looked at was these multiple wires coming from the condition downstairs. There was a second unit downstairs through the envelope, the building enclosure, into the alleyway of this building. And he just did a Hail Mary, and he said, "I don't know how to seal. How do you seal 50 wires?" So he just blasted it with foam. I started peeling away the layers that went around the wires, and it was clearly extremely. And again, that looks good, but it just did not work. So this work inspired me to do this work to figure out how can we have a lot of wires coming through and air seal them. So here's the work up here that failed. So this is a method that I came up with, and I've used this. This is a sweep, a 90-degree elbow that's used in irrigations, thin plastic. It doesn't have to be heavy plastic at all. You get a thin elbow. The wires come out of the wall from the alleyway, let's say, into the conditioned space. They go through this elbow and they come up and they run. Suddenly now they're running horizontal. You stuff in denim all around the wires, right? And then you here's that Chemlink elastomeric. You flood the top of this with, you have to tape this elbow to the wall so it can't leak here. You tape it to the wall, flood the top with elastomeric, jiggle the wires, and you have now air sealed as many wires as you want in a liquid lake bed of elastomeric.
Terry,
So,
we have a quick question.
Absolutely.
It's a two-part question. Does this harden, or is it always in liquid form?
It hardens.
It does harden. And the second,
yeah. Glad you asked that question. It does harden. I have samples not here.
okay.
It hardens to, this is one of the really awesome things about elastomerics. The properties of elastomerics, there's basically two fabulous properties of elastomerics. I mean, one of the things is they're water-based and no VOC, and but the ultimate properties of elastomeric is they have a lot of elasticity, like a rubber band. They can expand and can go right back to where they were. That is the key property of elastomerics. They pull apart and they go back where they were, just like a rubber band. They also have fabulous adhesion. They stick to anything. They'll accept water or Vaseline they won't stick to. They stick to anything, and the adhesion is incredible. And they do set up to different degrees. Um, like here, here's an elastomeric. It's almost like a latex. It's a rubbery latex. Elastomerics are basically latexes, and the properties they vary, but they set up just like like pouring rubber bands into the mix. So here's the final product of that elbow, and you can see the denim down here that was stuffed with a little garden tool, and then the top was filled up with the elastomeric, and this is definitely set. If you could grab this stuff and it would stretch out like a rubber band.
Awesome.
Yeah.
Second
okay.
part to that question.
Yeah.
Will this work as insulation for lead requirements that want insulation to wrap around the wires / pipes going through the structural framing?
I don't know. Don't know. I'm not that good. Actually, believe it or not, I don't know everything. So that's an interesting question, though. Lead for, I say, whoever asked that question, you'd have to do that homework on your own. I will be doing it. Write it down. I'm not quite sure I'm not totally familiar with lead, but I don't know what lead requires for insulation around wires. Is that a thermal insulation or an electrical insulation? That would be a question for me. If it's thermal, it doesn't have particularly any high thermal values. It may have a high enough value, I don't know. If it's electrical conductive, it does not conduct electricity at all. So I don't know if that answers the question, but that's as best I can do. Is that good?
Awesome. Thank you.
Yeah. Okay, so this is something else to pay attention to in new and retrofit work. Anytime you have a tube or a straw or a conduit running through a building, this is in a light can, right? Look at this light can here. This is light cans in the attic, and all light cans, the old ones, have these flex conduits going from the attic into the light can, and the light can, of course, goes down to the living room. So the heat from the living room is going to go up through the light can and go right around this straw in the light can and empty into the attic, right? Now, you don't think of stuff like that, but that's what it is. Here's another straw in a retrofit work. This conduit was feeding some kind of cable box, and of course it went up into the attic. So air is going to go from the cable box through this tube and up into the attic. A sub panel in a house, if the bottom of the sub panel typically has conduit, it can be on the top, but let's say it's on the bottom, very often on the bottom. That conduit, 2-inch, if that's going to the outdoors, that's a leak, right? You're connecting outdoor air to indoor air through this tube. Same thing when you have insulation around copper pipes or PEX or whatever. If you have hot water pipes or cold water pipes and you insulate with foam around them, and that typically when that pipe goes through the assembly, you can, if you air seal around the outside of this foam, air can still run through the gaps around the pipe and the foam. So the way that you can remedy that is you actually have to pull the foam back if you're going to air seal it. And then this has beds of elastomeric, and then the foam is put back in the around the pipe and you air sealed it. So these are little things you have to think about when you're trying to air seal a building. A lot of this is relative to how airtight you want to make your building. But what's happening is with Zero Net Energy is now suggesting or recommending 2 air changes per hour to air seal a building. Most contractors, I would say, may not even understand what that means, no less know how to achieve that. To get a building to 2 air changes an hour, you have to start paying attention to stuff like this, right? And stuff like this. Maybe not this, you might be able to get 2 air changes now without doing this. But if you start leaving all these elements out, you will fail your required air changes per hour. So we have to learn to get better at this. And I'm showing this is the way to do it. Gun foam. So this is my little expose on gun foam. Can foam, gun foam, it's fast, it's cheap, certainly it's cheap, and it's fun to use. I'm not sure, I always enjoy using it. It looks really cool. I'm not sure why, but it does. It's kind of like, I don't know, like having a whipped cream up in your attic or something. And it can do a good job. It can. But this is an illusion here. It's saying that that's air sealed. This is a total illusion. It's mostly air sealed, but how much is it going to leak? Well, I can tell you right now, here, 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 maybe behind there, maybe underneath this as well. This stuff isn't necessarily stuck to the drywall. So the can foam is, I equate it to kind of like, here's a duct going up from a crawl space up into a living room, and it's duct taped, right? When you duct tape pipes, HVAC pipes, it's probably pretty airtight for a while. And for how long? I've looked at duct tape that might be 20 years old and it's good. And I looked at duct tape that's 5 years old and it's not good. I equate foam somewhat to duct tape. So this is a story. Some years ago, maybe 15 years ago, when I started air sealing, I used gun foam, right? Because that's all I knew pretty much. And I knew air sealing was valuable, and so I air sealed everything I could possibly find. And on this particular job, subfloor here, bottom plate, I gun foamed the whole bottom of this huge gap in the bottom plate. I gun foamed it, and then before drywall, I took a utility knife and I cut off all of this fluff, right? This fluff's not the air sealant. The air sealing happens here, not in the fluff outside of it, right? But what you see is this, and this looks great. This looks cool, right? But maybe what you're getting is this. So in this particular building, sometimes you get this, sometimes you don't. I looked at that and I thought, wow, I thought this stuff, it looked like I was confused. I said, how much of my air sealing is not working? So I just decided to dive into foam. A friend of mine, he's an ornithologist, he said I could use his lab, and I took sections of cut foam from a can gun, dried up, and put them under the microscope, and I just wanted to see, what is foam? What does it look like? What does it feel like? What does it dry like? So this is a close-up of gun foam. Beautiful, right? Looks like leaves of cells from a leaf or something. So that's what gun foam is. It's these chains of propylene, polypropylene, no, not polypropylene, chains of urethane, something or others, and with little bubbles in between, and the bubbles are filled with pentane typically, and that's your air seal, these bubbles, right? And linked together by these polypropylene, whatever they are. I'm sorry, I don't know. But that's what foam looks like up close. And I was surprised when if you actually poke this stuff, it doesn't just pop. It's pretty resilient when it's fresh, right? When you touch it, it kind of bounces back. And I thought, oh, maybe it's not that bad. It does bounce back. But what I discovered is over time, this becomes brittle for different reasons. And when you touch it, it just breaks. And when it breaks, the air seal breaks. So I'm studying more wires. Here's a wire going through a foam bed, right? And you just pick up the wire and look at it doesn't stick to wires sometimes. Here's foam around a conduit, a liquid tight conduit, and you can see adhesion. This is adhesion here and here, but no adhesion in here and here and here. There's some down here. So it's like, it works sometimes and sometimes it doesn't. Here's a foam going through a plastic electrical box, and you could easily, when you push the wire, it would just flip out of the foam would flip out of the hole. I can show you a experiment I did. This is about adhesion. This is a plastic box, a typical cheap remodeling box, 49 cents. So what I did was I sprayed I sprayed 4 sides of this with a can foam, gun foam, and I let it set up, and then I just popped off all of the foam. And on this particular section here, I noticed that all the foam that was on there had about 60% adhesion, and the rest was not. 60% coverage, yeah. Over here, I'm sorry, this is the wrong one. But on all of these sides of the boxes, adhesion was between 10 and 60% adhesion to the plastic. Elastomeric on the same plastic box was 100% adhesion. You could pull and tug on this, and it would be a challenge to get it to come off. Where the foam was, where it was stuck on, was not bad, but it wouldn't stick to a lot of things. So I messed around with foam a lot. I just kept testing it. I went back to old houses and poked at it and cut it away to see how it actually aged into the building. But to me, the worst thing about gun foam is it gives the users a false sense of perfection. So these 4 shots here are insulated, very, very good insulated. It's really fabulous insulation, dense pack insulation, was a genius of insulation. And I went around, I followed around his air sealing. He also air sealed before he insulated. So here's one of his boxes. Looks great, right? How could that leak? With that much foam around the box, how could it leak? Here's a hole, right? And is it leaking back there? Who would know? Is it leaking behind there? Who would know? Is it leaking in that hole or that hole? Who would know, right? It just looks great. So here's another box, looking at it from the top, with the light shining in it, and it's definitely leaking from the top of the box, even though there's foam all around it. Here's the wires going through, here's the hole. Look at this crazy, this is ridiculous. Multiple wires going through a hole are extremely difficult to air seal with even the best of materials. But foam certainly is an absolute failure in these situations. This is just poor workmanship, but even good workmanship would be impossible to air seal 3 wires jammed into a hole. Another box, a leak. So you walk around, look at it, wow, it looks great. You know, who did this? But it's not real. One of the problems with air sealing with foam is it dummies down the craft and the skill of air sealing. Because you go around, you spray everything, you think you've done a job, but it doesn't connect you to air sealing. It doesn't make you understand what air sealing is. And it really dummies down the air sealing industry that doesn't exist yet.
Terry, I have another question for you.
Yeah.
Would putty pads around the electrical boxes be better than foam?
Yes.
Okay.
Yes, they would. Yeah. But putty pads will, under a lot of movement, the wires will push the putty out of the way. This is the difference between putty pads and elastomeric. If you move a putty pad around a wire, because the putty stays kind of a putty for a long time, when you move the wire, it pushes and makes a gap, and the putty doesn't return back to the wire like elastomeric does. But yes, it'll work. If the wires are undisturbed, it will work, and it's definitely better than not using anything, and it is better than using foam. So here's a little expose on foam. Here's a piece of foam. You can see it's about 3/16 by 3/16 thick. And we're going to give it the elongation test, the stretch test. So watch this. I'm pulling on it. All right, say no more. Oh, that didn't work. Oh, don't tell me it's not here. Oh, it's not here. Sorry. Oh, here it is. So I'm sorry. This is the same thickness of elastomeric, right? Stretched in the same way. Whoa, 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 whoa! Jumping around here. Hold on. Same thickness of elastomeric. That's 200, 300, 400% elongation. Well, maybe 300. This is about elongation. That is one of the key properties of elastomeric. It never did break, and it stretched out maybe 400 or 500%. Foam will not do that. Putty will not do that. When buildings move, parts move, you want the material to come back where it was. I like to think when I walk away from a building, sealing it, it can withstand a degree of earthquake. It can take that much movement. I also like to think if I walk away from a building air sealing it, that it stays that way. And it stays that way for a long time. It stays stuck and it moves with the parts and it's buried in the walls and it's going to last for 60, 70, 80 years. So how good is foam sealant? I don't know if any of you missed the first part of this show, but I showed about the properties of elastomerics, and their adhesion is fabulous, elongation is fabulous, flexibility is fabulous, and the longevity is fabulous. So here's my rating on foam from my experience of using it and going back and testing it. Flexibility is good to fair. It can flex. Elongation is poor, as you just saw in that previous slide. Adhesion is good to poor, as I showed you in that electrical box. Sometimes it sticks, sometimes it doesn't. Longevity is good to poor. I've pulled out foam that's 20 years old and it seems to be fine. And I pulled out other foam that was disintegrating around the joints after 20 years. So if you would you rate your plumber, if your plumber said our work is good to fair, our craftsmanship is poor, our the materials are good to poor, would you hire that plumber? Why are we willing to compromise on the materials going into air sealing and not compromise on the color of the paint on the walls, the where the wood came from the floors, or how much the kitchen or bathroom remodeled? We're willing to go all out on all parts of our building, but yet air sealing, it kind of gets no respect. Why are we willing to not up our game in air sealing? I think we will be, and it's just a matter of time. Oh, so here is this is the high bar. In a lot of my slides, you see I use tape on my high-end jobs where there's money or the people understand good air sealing. They're willing to pay for tape because tape sealing is the most expensive, time-consuming, but it is the 90-year earthquake air sealing, and here's why. Here's some tape wrapped around one piece of wire, and here comes a 6.8 earthquake. I think that speaks for itself. Okay, so this is a little quiz section here. So airtight boxes. I covered this a little bit in part one, but I came back to it because I didn't include this slide. And you've heard of airtight boxes, right? And this is one particular brand that I like. It's called Airfoil. And this guy has a little factory in Minnesota, and he makes these fabulous airtight boxes. And the way they work is thus. Here's an airtight box. You have wires coming from the outside, just like any other electrical box. And the wires come through this chamber right here. And they go through the chamber, and then they go into the electrical, into the box to be made up for outlets or switches. Here's the wires popping through. You fill up the chamber with elastomeric caulk after the wires are in, and here you can see the elastomeric oozing out of the boxes, right? So what you have here is you have wires running through, just like that mock-up I made on the wall. You have wires running through an elastomeric chamber that cannot leak. Even if you wiggle and jiggle these, they're in a half-inch bed of elastomeric. That's the way these boxes work. And they have big flanges, so when you put them on the wall and you put drywall on the flange, you can make it airtight around the box as well on the outside. So up is coming a question that it may be a little advanced, but I'm going to do it anyway. why would you not need, when would you not need airtight boxes in a building assembly? And I'll just lay that out there, and I'll move on slowly and give you a minute or so to come back with your answers. So here's an airtight box, which clearly, airtight boxes can actually go on the outside of the plywood, but these are mostly designed for indoor airtight boxes. When would it not be necessary to use an airtight box inside a building envelope? All right,
Terry, we have a question asking if these are new or retrofit boxes.
either. It's a hard question to answer because, yeah, new work, yeah, it's easy. You just put them on. And instead of using, if you're replacing a box, electrical box, you use these and they won't leak, right? Inside or outside. If you're leaving your existing boxes, you have to deal with those. These are only work if you're replacing your boxes, and that would apply to new or retrofit work, right? So they can apply to either one. I hope that answers that. Get back to me if it doesn't. So we're thinking about why would you not need these in an envelope? It's kind of an advanced question in a way, but let's see how good you do. On to case studies. We're kind of moving out of the gadgets and the things you need for air sealing. Now we're going to just learn from air sealing things actually on a job. Some of the jobs that I've been doing over the years. So here's a job. Our utility company up here, PG&E, wanted to have a zero net energy model house mixed into a mixed affordable housing community. And they built, there was 15 units there, and they designated this one to be zero net energy house. And they were going to compare over the years the energy and the comfort and how this house performed compared to the other ones. So I got a call after the house was, this is still the dirt phase. There's no landscaping. The house has not been lived in yet. It's just still being worked on. But I got a call to this house, and it was finished. The drywall was on, the paint was on the walls, the kitchen was mostly installed, the bathrooms were mostly installed, and they were required for the zero net energy requirement to get 2 air changes an hour in this building. But they, what happened? Let me see if I can move this. The target number to get was 345 cubic feet per minute, which also equals 2 air changes an hour. But when they tested it in, they were testing at 781 cubic feet per minute. So they were not hitting their target. Whoever built the building, he had never attempted air sealing before. He did a really good job, but because he didn't understand air sealing, had never done it before, he missed the target. And the utility company was really married to ACH for part of their study and their grant money. So they called me up, they were frantic, and said, we're not hitting it, what can you do? And so, whoops, sorry. I'll tell you what was done, the pros and cons of what was done here. The target leakage was 2 air changes an hour. The pressure boundary, the air seal, the airtight layer was established at the floor, which was a slab. And then it went to the exterior plywood that had blue skin on it, which is an airtight layer. And then the drywall, inside the drywall ceiling was the airtight layer. That was basically it. So they did a pretty good job air sealing the envelope. The air sealing was not very specific on the plans. So the first time contractor didn't really have a lot to go on. There was some vague things on what to do. There was no training for the air sealing specialist and little supervision. The attic was all gun foam sealed. And you'll see it looked fabulous. It looked really air sealed. And biggest problem was they brought me in too late. They brought me in to try and lower the numbers, air seal it more, when the whole building was already fully enclosed. Big mistake. If you want to get your numbers, it has to happen before you put on insulation, before drywall. That's your last chance to make your building tight. So here's the attic. Beautiful attic, generous, really nice attic, well designed, truss attic, and all the air sealing is gun foam everywhere. So that was my one opportunity. I couldn't get it any parts. So I did some testing and I found out. So here's what I found out. I went around the attic and here was air sealing in the attic. Multiple wires again going through a hole. I know that's not going to work. Um, air, I mean, everything was just bombed and flooded with foam, right? And it looks fabulous to the average eye. Here's a foam pipe, right? Remember I said this is a straw, and you can't just air seal the outside of the foam. You got to pull it back and air seal inside the foam where the straw goes through it. So this is what I'm looking at, and I thought, suspect. I started popping off all of this superfluous foam stuff. These big clouds are not sealing the hole. They just are left residue from overusing the gun foam. So I pulled off the big superfluous fluffs of foam around it, and this is what I found. I found one thing: they were trying to air seal on top of dirt. That's not going to happen. Nothing's going to stick to this dirt. This is powdery, dusty dirt. So this hole should have been cleaned, absolutely cleaned, before he attempted to fill it up with worthless foam. So here's adhesion to that wire, adhesion, no adhesion, adhesion all along here, but no adhesion under the wire. Maybe adhesion under this wire, no adhesion under any of these wires for sure. And here's the hole, right? But yet it was covered up with foam that didn't address the hole. Here's another hole, right? And I thought, oh, okay, I'm onto something. I started popping off every foam pillow. Here's another foam pillow around the hole. Here it is taken off. Here's the hole. More air sealing, multiple wires. I know that's going to fail. A hole. And I pulled off the foam. More holes. More holes. So that was my one shot at reducing the air leakage in the building because I couldn't get access to anything else. So what I did was I went up and I pulled off all of the superfluous foam, and I, using a brush and elastomeric, I brushed and flooded all of the wires that had foam around them and holes underneath them. Now here you can see the sealant. With foam you can't see it, but you can see this liquid surrounding all of everything that needs to be sealed. Here's a real mess of lots and lots of holes in there. I pulled everything back, pulled the foam back, and air sealed it. Vent going through, same deal. I left this pillow here so you could see. You put liquid elastomeric over. That's the air sealant. The foam is just a gap filler. Wires coming through, wires coming through, wires coming through. What was I going to say to that? So after I came in, it took me actually 2 days. It cost a lot of money. A lot. It was a 3.5 hour drive for me down to this place, but they were so stuck on getting this number, they wanted to lower it. And after 2 days of two of us messing around with it, we finally got a blower door and got it down to 320 CFM air changes per hour. I mean, cubic feet per minute. And we achieved that target. So we spent as much money catching up to the ceiling as they spent on the whole air sealing. Again, uninformed contractor, no experience with air sealing, no knowledge of how to air seal. Here's another job, new construction, San Francisco. It was this 4-story with a basement, a garage basement in San Francisco, and I got called into this. This contractor wanted to build this building. It goes back that way. It goes back here too. He wanted to build this zero net energy building, off the grid building, and had never really done air sealing before. And he was smart enough to call in somebody who could help him with that. You know, he just had never done it. He had no idea. So I worked with him, and we came up. Basically, I designed the air sealing of the assembly of the building, and it was the walls were framed. Whoops, sorry. Walls are framed somewhere else and brought in and assembled. So I worked with the contractor. We sat down on paper and slowly worked out the air sealing assembly. And basically, the assembly that I designed was based on using gasket sealing. So they were gasket sealed in the factory, they were brought in and then assembled with a gasket sealing. So here's the story of that building. The target air tightness for that building was 0.6 air changes an hour. Now that is extraordinarily tight. That's passive house. But for a large building like that, it's quite a challenge to get a building that tight. When we first went in, it was leaking way more than that. It was a disaster. And after spending a lot of money, we got it down to just below the 0.5, 0.6 requirement. 80% of the building was gasket sealed. If you missed that in the first part, sorry. 10% was tape sealed and 10% was other, mostly caulkings and elastomerics. The crew and the contractor had never attended such a tight building, but we were successful because they brought in somebody who could work with them and teach and train them how to do it. I didn't air seal it to that tightness. I worked with them and taught them how to do it. This is what I like to do the most. I don't like to do the work. I like to teach people how to do this so they can do it on their next job and their next job. I met with the crew before it started, and we established the person who was in charge of air sealing the whole building, in charge of the crew and the people that did it. I did periodic site visits for coaching and quality control, which was key and critical. The target CFM for the whole building was 639 CFM. The first blower door test was 4,000, and the contractor freaked out. But we got it. We 6 running around. We actually finally did get the numbers down by finding leaks. So here's planning. Here's a contractor, and we were planning on how to some of the air sealing strategies. Planning is key. Air sealing starts before you pick up a shovel or a hammer. That's when air sealing starts in a building, retrofit or new. Here's the building being assembled down the street level here. These big cranes would lift these panels up, drop them on the first floor platform, and then there were gaskets sealed around the edges of the panels. You can see those 2 gaskets there, and then the walls were dropped on top of gaskets, right? So imagine you drop this wall on this beautiful gasket and air can't get under it, and you put this wall against another wall and air can't get between the walls. That was the plan. So the walls were set on top of gaskets, and it went up 4 stories like that. Here is a gasket before the wall came onto it. Here's a side wall with gaskets stapled onto it. So when it met the other wall, it was tight. Here's a wall being dropped on top of the gasket. That was the basic plan. Here's another top plate with gaskets. And here is some tape sealing underneath the wall, underneath before the gasket went on. Final test was 0.5 air changes an hour. Now this guy here, he was the person that wanted to work with me, and he wanted to be the designated air sealing specialist. And I said, okay, you're it, and anybody can do air sealing, but you, not till it passes by your approval. And I worked with him directly to achieve this airtight building. And he was blown away. When we finally hit the number, it was a very expensive, very painful, and arduous. But we finally hit the number. The contractor was ecstatic, and the worker was just like, "Oh my God, we actually did this!" It was quite a feat in this particular building. So here's a jump away from a lot of the air sealing that I'm used to, and I do. This woman, Bev, she heard that she heard about my reputation of air sealing and blah, blah, blah. And she called me up and she said, my house is just, I'm thinking of selling it because I can't, she was very, very sensitive to fumes and toxics, fumes and smells. And she said, I spent all this money and it's just, it's not working for me. So I went in there and did spent a day doing an evaluation of just the house in general, and came up with a plan. So this is what she wrote, though, after we finished the work. She worked with me. She was fabulous. She actually got down on her hands and knees, crawling around, air sealing with me and tape sealing and caulking. 3 years ago, I bought a 1980s house with a goal of doing a green building makeover. I spent a fortune on efficient windows. She had really good windows, new HVAC, insulation, etc. But the house was still drafty. This house was on a hill, and it was particularly vulnerable to high winds. It was a very windy location. Now, if you're building in a windy location, you better be extra double sure that your house is airtight, because that wind is going to go through the holes. It's just going to go through the holes. That's just what's going to happen. The only way to stop wind from going through a hole is to plug up the hole. It's like a flat tire. The only way to fix the flat is to plug the hole. But the house was still drafty, it smelled bad, and the HVAC ran all the time. I was thinking of selling my house. After 4 days of working with yours truly on air sealing, it's like a different home. Warmer, drier, dramatically more comfortable, and the spiders are near gone. That was an amazing comment. She said, the spiders are gone. We had no place to get in and out. Who knew air sealing could make all the difference? So we tested in with a blower door. Her house was leaking 2,000 cubic feet per minute, and we tested out at 1,000 cubic feet per minute, a 45% reduction, doing something I had never really done before. I went outside the building, and this is the windward side, and the crawl space was way over vented, and it had a vapor barrier on it. So with the vapor barrier, it didn't really even need venting. So I closed off all of these outside vents facing the wind. I closed off about half the vents in the crawl space, which immediately stopped the crawl space from pressurizing from high winds, right? And then we just went around with, I don't know, it was like 60 tubes of latex elastomeric caulking, and sealed around the doors, the baseboards, under the stairs, in the garage, under the drywall, just sealed every connection in the place with caulking. In the floor, there was a trapdoor, hatch door into the crawl space, had no gasket. We put a gasket on it, foam gasket. There was just some tape sealing and some open duct work behind the heater vents. And then we went around to all the outlets and put these extra thick outlet gaskets on. If you're gonna put gaskets on the outlet, make sure they're thick, not these thick like this, not the thin ones. And then this was her idea, it was a great idea. She put childproof plugs over all of these to slow down the leaks in these. And it was many outlets and switches. And so that we were cutting down air leakage from the inside, which is something I don't do too often. Here was an opportunity to tape seal an interior cavity with cabinets below that opened up into the wall spaces, which connected to the crawl space. So that's what this tape sealing is all about. Light cans up in the ceiling. Here's gaps. This is a hole cut in the drywall. Here's the metal light can, and these are the air gaps directly into the attic. Stuffed them with different kinds of foam, and then put elastomeric over the top of the foam, right? You can see it around there. And I air sealed inside the can. I reached inside the light cans and used tape to air seal. Light cans are not airtight. Even airtight light cans are not airtight. So what you have to do when you get to a light can is look inside. Before you put it up is the best time. Before you put a light can up, put it in your lap and look at it and see where the air is going to come through. All of those seams that are just bent and folded can leak air. There can be lots of little leaks in a light can. So I tape sealed the inside, stopped that leak, then I stopped the hole in the drywall leak, and then put LED lights in those, and cut out pretty much most of the leakage in the, there was dozens of light cans throughout the place. So that's how, just doing that, that's pretty cool to think about it. Just
Hey, Terry.
doing that. Yes.
Is now a okay time for a 5-minute break?
Perfect.
Okay, excellent. Everybody will resume back around 2:06.
So here's another case study. This is it's a ranch house. I like ranch houses. They're kind of standard middle America houses. There's billions of ranch houses or versions of ranch houses all around the US. And this is a traditional classic garage ranch house, and I was called in. Um, I actually sold this job. I wanted to air seal the attic only with my new invention, my elastomeric product. And I came in with another guy, and we air sealed the attic only. That's the only work we did on this house. Access was pretty good through the garage. It was a good way to get in without going through the house. And when I got up there, the insulator had cleaned and vacuumed the attic and prepped it up for me to air seal. So when I got there, all I had to do was air seal, no cleaning. I tested him with a blower door, and it was leaking about 5,000 cubic feet per minute, leaking in the attic. After 2 days, me and this other guy and this elastomeric we spray, I was faster. 2 days of air sealing. I mean, one day, two guys of air sealing. We tested out about half the leakage, doing just the attic. Right. So it shows you what's possible, how to make a big dent in a building, new or retrofit, by making sure the attic is really airtight. Another job, I call this the Creekside House. This is affordable housing group organization out here. I did a lot of work for them when I looked at their buildings before they bought them, and then worked on them if they needed work, and they all did. So this house was a disaster. This was it had not been lived in for a year and a half, and it was just fabulously moldy, horrible, scary place. Inside, the attic was full of rat-infested insulation. The place was the crawl space was wet and moldy, and it was a terrible place. It was a bank sale. Nobody would buy it because it looked so scary inside. But I looked at it with our affordable housing group, and I said, no, this house is fine. It just needs to be fixed. It needs a little bit of tweaking. So we basically, I tested him with the blower door. It was leaking 15 air changes an hour. That's a very, very leaky building. That's a little better than living in a tent. And when we got all done, we remodeled the inside. We completely redid the kitchen, the floors, put in all new doors and windows, but the outside was left the way it was, and it got a new roof on it. It got a partial remodel. All the drywall was left inside, pretty much. And we tested out at 2.3 air changes an hour. Now that's quite a reduction, doing basically just the attic and the crawl space. And again, this attic was done to the level of this attic. It was done really well. Very, very air sealed, as was the crawl space, this place. Here's what it looked like, it's hard to believe, when it was finished. So this shows you, this is what we can do. I mean, this is such a typical building, and this is such a typical building. We can actually really air seal them if we're willing to spend money. I mean, this was some thousands of dollars. I'll show you how much this costs, but it's thousands of dollars that starts paying itself back. What do you do in your house that starts paying itself back? I know carpets don't, kitchens don't, but insulation and air sealing starts paying, the meter starts running backwards. It's one of the only improvements you can do that pays itself back. And yet we're not willing to spend money on it. There's another house built in 1926. This was my first attempt at air sealing a house. This was a pretty small house, just a 2-bedroom house, small, with old redwood siding on it. And they tested it with the blower door at 21 air changes an hour. That is fabulously leaky. But yet here it sat there for 80 years, 90 years, leaking like that and just pumping heat into it. Tested out at 0.9, under 1 air change an hour. That was my first attempt to air seal. In the attic, we used R42 insulation, blown in cellulose after I air sealed it. The floor was R21 dense pack after I air sealed that. The walls were R17 after I air sealed that dense pack with 1-inch foam on the outside. Basically, the strategy for this was it was all air sealed from the outside. The siding was taken off. It had to be. I removed the porch. See the way this porch is slipped out from the building? I thought, if the porch is attached, I have to work all around this attachment here to air seal it and to insulate it and to do everything. And I figured it out. It would be cheaper and much, much better job to simply remove the porch, pulled it, I rolled it out on rollers, and then I could just work on the outside of this building as one continuous building shell. That was the strategy. So here's the air sealing story of that building, that house. First time, nobody, including myself, had any idea how to air seal. It was a very low budget. I was the only air sealing specialist on the job. No one else was interested in doing it. It was all done from the exterior. The only thing that was done on the inside was the kitchen and a new floor in the living room. All the other carpets and everything remained in place. All the drywall remained in place. The masonry fireplace was taken out and all siding was taken off. And the main reason we were able to get it so airtight is because we had good access. Air sealing is all about access. If you can't get to it, you can't air seal it. In this particular building, we had good access. The pressure boundary was established at the sidewall, the new plywood that went on it. And it was all gasket sealed. The plywood was gasket sealed onto the framing. The floor was tape sealed from underneath. And the attic had, I air sealed it by using a two-part foam gun seal, which was the most horrible, terrible work I've ever done in my life. And that building was what got me to just run as fast as I could away from foam. It was really, really nasty, horrible stuff to be around in large quantities. Here's the fireplace being taken out. Here's the underside of the floor. So the house needed a, let's see if I showed it. So you see down here, the house needed a new foundation. So we actually put cribs under, we jacked it up an extra 1.5 feet to make more room under there and put a foundation under it. So after the house was jacked up, it was a generous crawl space, clean, and I put visqueen on the floor, 20 mil on the floor to make it vapor tight and dry and pleasant in there. And the strategy here was, since we didn't do any work inside the house, we went on the underside and air sealed the floor. Because like I said, the carpets were still left in the bedrooms. So we air sealed the floor from the underside and the plywood siding from the outside. So here's the outside of the building. Again, the walls were left intact. The framing was left intact. The siding was taken off, and we put new sheets of OSB on the building. And this cool thing here, this insulator, what he's doing here is after the floor was enclosed with these empty cavities in it, the insulator came in and dense packed the cavities, filled up all the cavities with dense pack insulation. And this tube was merely slipped in way into the other side of the building and dense pack coming out. Another case study, the Midori House, Santa Cruz, tested in again, 15 air changes an hour, massively leaky building, but typical. You know, I mean, this is not an exemplary building, extraordinary building. This is another building on the block, and this is the ability for it to leak air. This is what we're living in. I mean, fortunately, we're not building things at 15 air changes an hour. We're down to maybe 5, might be an average. 2 is 2 air changes an hour is zero energy recommendations. Passive House is drawing huge respect in demanding that buildings be airtight, almost half an air change an hour. I compare that to 30 times leakier in this building. So that means 30 times less heating and cooling is going out of the holes. This building was tested out at 0.6. This was going to be a Passive House retrofit at 0.6. I worked with the crew. I was an air sealing consultant. I worked with the crew, taught them how to air seal, and did some coaching and quality control. So this is what's possible. Now this was expensive, but this building was all about access to the parts. Right? So here is why we could get this building really tight. From the outside, we could put a skin on it, a balloon skin, an airtight layer, and make it really airtight. And then from the floor, nope, wasn't done there. The floor of this was done just the way they actually mimicked. They copied what I did here on a lot of levels, respects, and the airtight layer was done under the floor. They crawl underneath and use sheet foam instead of OSB to cover the underside of the floor. So here's the air sealing story of that building. Target ACH 60 achieved that. The architect knew the values for energy efficiency. This is a key item. If the architect comes in and working with the client, of course, and knows what the energy efficient values are, and knows what air sealing is, and the client wants it, the architect comes in with that and makes sure it gets done. Hopefully, getting it on the plans and then doing some follow-up to make sure it's being done. Total access to the parts. The informed crew, the contractor and his sidekick did all the air sealing, and they got it. You know, so some people I work with, they just get it. It's not rocket science. It's not difficult. Sometimes there's resistance where contractors or crew members will say, "Oh, that is so stupid. That is ridiculous. Who cares? Oh, that's ridiculous. How are you going to breathe?" A lot of negative flack will come back at you. But this crew, they got it. They understood what it was and the value of it. The client was willing to spend the money. That's absolutely key and important. The airtight layer was established. It was gasket sealed on the exterior plywood. The drywall ceiling was the airtight layer, and it was tape sealed under the floor. That was basically the airtight layer and the materials used. Blower door test was done at the right time before installation, and we tested using hand feel and mini smokers. Again, the first test was 17,000 CFM over target, but eventually we kept at it and got it down to the 0.6. To allow airtightness. There's another job, I call this the Shiv House. This was in Cupertino. This is one of those jobs where the owner never said how much is it going to cost. Got to love those jobs. When he said, I want it as airtight as possible, just as airtight as you can make it. And he never said how much is it going to cost. So I got the best materials, trained the crew, and the strategy on this was to tape seal pretty much on the outside. But what's interesting about this is when I had the first meeting, this is a contractor, this is the client. I had my first meeting with these two people and two architects, these two women architects. And we sat down in this room and they showed me the plans and they said, can how are you going to air seal this house? And this house, this is the entry. And I said, I cannot air seal that. Or if I could, it would just be mind boggling. And they would both fell out of their chairs and go, what do you mean you can't air seal it? That's what you do. Well, how could you not air seal this? That's what you do. And I said, well, this is there's like 10,000 light cans in here and amazing, just convoluted framing, really extremely difficult to air seal. And they said, well, what can we do? So I said, okay, I got an idea. I said, this is what we're going to do. The airtight layer as drawn was typically in the drywall ceiling the way it is. So all of this ceiling stuff here would have been drywall, these multiple layers with the billions of cans. That was the airtight layer on the plans. I said, if you want to make this easy to air seal, move the airtight layer up to the roof, right? Here's the balloon skin on the roof, right? And it's taped. So you look at this entire roof and it's sheets of plywood, which are pretty tight, and all the seams and joints are tape sealed. So that's now airtight. The simplicity of that, rather than trying to make all of this airtight. And the owner said to one of the architects, said, can we do that? And the architect looked at the other architect, and they went back and forth with the looks, and she said, I don't see why not. So they just simply changed a few things and made this the airtight layer. And of course, the insulation would then have to follow that under the roof rafters, and a plan was made for that. And we went at it and got this to 1 air change an hour, pretty much right out of the gate. We came in, it was leaking a little more than that. And after a day, we just got it down to 1 air change an hour. And the client said, that's it, I'm not willing to pay for any more. So that was a respectable number for a large complex house. Architect, contractor had no experience in air sealing, but open to learn. The reason I'm telling you these stories is because these are the stories that happen when you're trying to air seal buildings. These are the things that come up. These are the reasons for failure, the reasons for problems, and the reason for successes. The target air change an hour was, as I said, as tight as possible. There was no target. There was plenty of money, which really helps always to achieve anything you want in a building. I gave on-site training to the crew and the contractor. There was a designated person to do the air sealing, and he worked with people under him. And I did inspections along the way to make sure he was doing the right thing with his people underneath him. It was 95% of the building was tape sealed, and 5% was other. So primarily the air sealing on this entire envelope was tape sealed. The pressure boundary was established at the outer plywood skin. That was the basic airtight layer. And we tested for leaks mostly not by infrared or anything, but by hand feel and smokers, mini smokers. The only problem with all of that was the blower door test. There was siding on the building, which kind of makes looking for leaks a little more challenging. But other than that, it was a pretty smooth operation. Here's more air sealing. Here's the roof. Again, tape sealing. Now notice over here, here's a penetration. So this plywood is the airtight layer, the balloon skin, right? So anything, here's something interesting. Once you establish this on the roof, right? This is important to know. None of this has to be air sealed. No air sealing whatsoever needs to be done down here. You're done. Why are you done? Because you've already established the airtight layer here. And how many airtight layers do you need in a building? You only need one good one. And plywood with tape on it is one good one. So that's why suddenly it became simple. So that's why suddenly this complex air sealing became really simple. You could just stand on the roof and air seal it. Here's a puncture in the plywood. Tape seal had to be tape sealed around it. All the joints and seams are tape sealed. And the rafter tails, tape sealed around them as well. Here's another part of the building, tape sealed. Inside, this is an outside enclosed patio, porch heated with conditioned space. Okay, now we jump to another building. This one, massive, this is probably a record. Actually, I did have one higher than this. This leaked at 22 air changes an hour. This was an oyster company up where I live, and they called me in as a building shell consultant and air sealing consultant in general. And I worked with there really was not much of an architect. The architect just sort of dropped off plans and moved up to Alaska. There was very little plans to work off of. So I worked with the contractor mostly and the client, the owner, who was pretty savvy about better buildings. And we just went at it and tried to make a better building. And I led the way with the air sealing part of it. Tested it in 22 air changes an hour. Tested out at 1.2 air changes an hour. Very respectable exit number. Again, it was about access. Whoops. It was about access. So the building was gutted. There's more offices back there. It goes down for ways. The building was gutted. And so it's easy to answer. You wrap the whole thing with plywood or OSB, and then you have the beginning of a good airtight layer. So there was no target air change tightness. It was just as tight as possible. The money was good. Informed crew, got it. These are good points, check marks. There was a designated air sealing person. There was good access to the parts. So this is why it was successful. This is why you could take a building that leaks 22 air changes an hour and make it into leak that much. This is why it's successful. It was 40% tape sealed, 50% gasket sealed, 10% other caulk and foam. Testing, it was tested when it was fully closed in and there was no siding, so it was a good time to test and find more leaks. The worst part about this assembly was there was overheating from 10 occupants inside the office, more than it was designed to be. So it was overheating and there was too much West glass, which really killed it. But in terms of airtightness, it had an HRV in it as well. Here's the roof being assembled and tape sealed. Underside of the floor, tape sealed of all the joints. These multiple wires were caulk sealed. Tape seal was used whenever possible. The underside of the floor, this was interesting. Right now, if you were standing here putting this foam up and it was high tide, the water would be up to your knees while you're doing this work. So the work had to be done in between tides. But the underside of the floor was tape sealed on the subfloor and the finished floor inside the office. And then there was additionally air sealed on the outer layer on the bottom of the joist. And it was air sealed using sheet foam, 1.5-inch polyisocyanate, and then tape sealed around the edges, puncture, tape sealed, punctures, tape sealed. The sheets were tape sealed to the girders, the beams holding up the joists. The reason this was triple air sealed is because the underside of this building was subject to no sunshine, reflective sunshine off the water. It was subject to high winds, high moisture. It was on the water and cold, and possible waves in a big storm. Waves could splash up and hit the bottom. So I wanted to be. I never do double, triple air sealing, but on the underside of this building, I chose to make it vapor tight, not vapor open, and super airtight, so that moisture could never get from the underside of this into the building. That's it for case studies. So now we do how much does it cost? So here's some of the houses we looked at. The Midori house, that old 1929 house, I think it was, it cost about $6,000 to air seal it extra to a very, very airtight number. The fancy house in Cupertino, it was a $1.7 million job. It cost $10,000 to air seal it to 1 air change an hour. The Florida Street, that condo, the 5-story condo, cost about $5 million to build, cost about $32,000. I'm going to guess it was 35 at least to air seal it to super tight. The case study job for the utility company cost about $2,200 to air seal it to 2 air changes an hour, after they spent an additional $3,000 for me to come there, drive a long ways and fix it. So the air sealing on this should have been $3,000, and it was actually $6,000 to air seal that, because they went at it without proper knowledge, without proper planning. The Blue House retrofit, that was my first attempt. Cost about $4,000 to air seal it below 1 air change an hour. The Hog Island, the Oyster Company offices cost about $5,000 to air seal it to 1.2. Creekside House, the moldy retrofit house for the affordable housing, cost about $3,200 to air seal it to 2.3 air changes an hour. And the attic only costs about $2,000 to air seal it and get a 49% reduction. Now, these are really approximate costs. I did not keep accurate costs. These are approximate costs for air sealing, my cost for air sealing. The cost will always go down after we get better at this and more experienced, and cost will go down on all our air sealing. Unfortunately, there's not a lot of data on how much it costs to air seal particularly retrofit work. New construction is a lot more accessible because a lot of new construction is being calculated through passive house, the cost for air sealing. So we need, as time goes by, we will gather more information on how much it costs. But you can see it's not, it's not cheap. $10,000 to air seal it was a $2 million home. $10,000 to air seal it's not chicken feed. But once this is done for the life of the building, and the payback starts right away. Again, how much do we pay to have a remote control thing on our keychain that opens up the rear hood of a SUV? All of these things, we pay so much money for so many improvements we don't even think about. I mean, cell phones are up to $600-700 because they have wide angle lenses and they can, whatever they can do. We're willing to pay that easily, well, if we can afford it. Yet we're not willing to do this to our buildings. It's kind of perplexing why we haven't decided to do this to our buildings. I think mostly because, well, there's a lot of resistance in the construction world. People think it's stupid or useless, and you're paying for something you can't see, right? You put in a new kitchen, you go, whoa, that's worth it. $80,000. It was a lot, but you know what? I'm glad I did it. So here's a job I'm working on currently. I'm working with an architect, a zero energy architect in the Berkeley area. And he brought me in to be the air sealing person on this project here. The ground has not been broken yet, but the estimated construction cost is going to be 1.75 million. Believe it or not, construction costs are way up or more. And the estimated cost to air seal is going to be about $15,000 for this building. The target leakage is less than 1 air change an hour. Now, the target leakage is something I made up. Originally, they started out saying that, they would be happy with 2 air changes an hour. And I said, if you work with me, I can almost guarantee you that with new construction, if we work together as a team, I can get you less than 1 air change an hour. And so that's what I'm coming in at. And they believe me. I believe myself. I believe I can do this. It's not that hard to air seal a new building once you know what to do. So here's this typical ranch house. After insulation is removed, it can take 30 hours to do a good job, 30 person hours, and $250 in materials. So let's say it's $2,000 to air seal an attic on a house, right, and drastically cut down the leakage and greatly increase the indoor thermal comfort. For those of you who missed the stack effect part 1, stack effect, the leaking attics are an essential part of stack effect, and stack effect keeps the thermal comfort indoors at a great compromise. It's hard to be comfortable indoors if air is moving from the holes below to the holes above. You shut off the holes above and you begin to achieve indoor thermal comfort. To do a crawl space can take 10 hours. It really depends on the crawl space, the access. But let's say it costs $1,000 to air seal a crawl space. You can see I'm bumping all these numbers up because these numbers were back some years ago, a couple of years ago, and I know everything costs more now. And your job may cost more. You might be able to do it for less. But I'm bumping up numbers because materials are constantly going up, and so is labor. Sidewall, to air seal sidewall, it's almost impossible to figure out cost because it depends on just how much you're taking off and how deep you get in. It could be as little as $1,000 to air seal sidewall, or as much as $3,000, and between $500 and $1,000 for materials. So these are giving you some baseline numbers. So when you sit down with your clients or your contractor, and you sit down with your clients, and you say, we're going to air seal this, and we're going to get it 2 air changes an hour, somebody's going to say, well, how much is that going to cost? Here's some numbers, you get some starting numbers. What is that? Your numbers may vary according to location and crew members. Too much money for air sealing? Okay. Viking Range Series 5 Series costs $5,000 plus labor. A 10 by 12 basic deck costs 3,500, 4,000. These are money. This is money. A lot of money we're willing to spend on a building. Um, these are mostly glitz and glamour things we can look at and touch. Air sealing is not, right? So this attitude hopefully will change, and people will realize the value. What is the value of a pedestal sink compared to the value of air sealing? They're different kinds of values, you know. When to stop air sealing um, and start ventilating. So ASHRAE 62.2, that's the Bible for what to do about air sealing. They have, you just go to ASHRAE. If you want to know anything about air sealing or regulations, go to ASHRAE 62.2. They say 7.5 cubic feet per person plus 3 cubic feet per minute per 100 square feet. That's it's like a guideline. The problem is they just say that's in the building. They don't say distributed or balanced. A rule of thumb for venting, you need 60 CFM per 1,800 square feet, with like I think three people living in the house, or 4, or 40 CFM ventilation for 1,000 square feet. Rules of thumb. I kind of ignore all of these. I just make buildings as airtight as possible, and they all get ventilated. So I bypass all of this, knowing that my building is going to be tight, and we're going to ventilate them. And we'll ventilate them according to ASHRAE 62.2 or better. So after you get your building really tight, ASHRAE says you have to ventilate it. Building codes say you do. What are your choices, right? I list 5 choices here. There's something called exhaust only. Basically, it means you have a bathroom fan running all the time, and it's just pulling air out of the house at whatever CFM is required, 60 CFM or 40, whatever is required. It's one source ventilation. It requires a leaky house for makeup air. When you're pulling air out, it blows heating out with a fan. You heat the house, and then you put a fan and blow it out at high speed, and it can draw in pollutants and unpleasant air from the air coming in. Where's it coming in from? Supply is basically the flip side of exhaust. It brings air in and from outside, and then your building will leak to the outside. There's balanced in and out fans. It's a kind of a more sophisticated system with more ducts going into more rooms, and it has air coming in and out, but it still relies on holes in the building, and it still takes your heat and blows it right out of the holes. And it can, all of these first 3 things all result in unpleasant air mixing. In fact, the air mixing is ridiculous. There is no, it is like one source air mixing. Now, so this is HRV and ERV. This is the kind. This is what we're going to do. This is the go-to thing. For buildings, when we make them tight, we're going to put in this sensible, I call it sensible makeup air, sensible heat recovery. It recovers the heat, it balances the airflow throughout the building, and it reduces stack effect. I'm going to go over what HRV are and how they work in our buildings. The 5th one, the really cheap one, and we can do this in California most of the year. You don't need ventilation, just need to open a door or window, right? Most of us do that. But go to Minnesota and try and open a door or window in January. So we're going to go over, ridiculous exhaust, ridiculous supply, balanced in and out, a little better. They're ridiculous because they're blowing heat out, and they're pulling air in where the building is going to leak anyway. You let the building leak, and then you suck air out. The only difference is you can control when the building leaks by flicking the switch. Heat recovery ventilator, HRV, energy recovery ventilator. Here's how it works. I'll show you what it looks like before you see how it works. So here's what that's a big thing, right? So this unit is pretty large. You need a space for it. You need to plan for this. I'll show you smaller ones. You need to plan for these. You need to have a large closet or a utility room or something to put this in. And then you need to have a lot of room to run these octopus tubes into the various rooms, like here. So here the ductwork for the HRV is happening up in the attic, right? It's happening in the attic because the roof is already the conditioned roof. It has the insulation airtight. So that's HRV is a serious business. Here's the way it works. It's got a 6-inch. This box here has 4 6-inch tubes there on the top. One of them is sucking in air from the outside, fresh air, right? Now air comes in, let's say it's 40 degrees, and it drops down into this core heat exchanger. So that cold air runs through all of these billions of square inches of surface area, and they pass through that surface area, and then the fresh air, and then it goes into the rooms, right? Outside air goes through here. And why does it turn red? I'll show you why. And it goes into the rooms. 40 degrees outside through the heat exchanger comes into the rooms at 61. How does it get from 40 to 61? Because at the same time, you're sucking stale air in from the house at 68 degrees from different rooms. It goes into the core heat exchanger, and it doesn't pass air to air. It passes surface to surface like a radiator, and it exchanges the warm air going out, exchanges with the cold air going in to the rooms, and then it's exhausted out. So that's fresh air in, exhaust air out. So what happened, but the beauty of a heat exchanger is you're recovering the heat recovery, energy recovery ventilator. And all of these other systems recover nothing. They just waste, right? Expensive, very cheap. The future, hopefully the past. Not yet. We're still doing that. So here's what one of the beasts look like. So we have to design this into our houses. If you're doing new houses, you can easily design it in, and you have to design the ductwork. You know, you've got to think about this. I've done a lot of remodels where you just figure out how to make these things fit in there. You can put them in semi-unconditioned spaces. They don't work quite as efficiently. You have to do a better job at insulating everything. So the minimum recommended supply air per person is 20 CFM. This is the heat recovery, their numbers is 20 CFM per person. That's pretty simple, right? 4 people, 80 CFM. 10 people, 200 CFM. So 10 people is a party, right? 20 people is a party. So what do you do if you have a party? This thing will not handle the ventilation, so you open doors and windows, right? You can assist an HRV with opening doors and windows, or you can turn it off and open doors and windows. So the beauty of this system, these whole house ventilation system, is that it's really balanced. Every room in the house has air moving in or out of it in a balanced kind of way, unlike any other system where it might be like these systems here. These are small spot HRVs, I call them, or ERVs. So this system right here is German, Lunos, and it's designed so that you punch a hole in one end of the room, and you put this little box in, and this unit goes into it, and then you punch a hole in the other end, and you put this into there, and they oscillate back and forth, sucking and blowing and pulling heat back and forth, and recovering. They pull in fresh air, and they recover heat right in this little box, and some of the fresh air and the heat comes back into the room. Very cheap solution for without. You can go into any room and put one of these in and get air, fresh air circulating back and forth. However, if you have this in the living room, the bedroom's door closed, you're not going to be getting too much air exchange in the bedroom or any other room or an office. So they have the limitations. So you say, yeah, putting in one of these into a house, what did I say, could cost, didn't say, could cost, $15,000, $10,000. You can put one of these into a room for, let's say, 2,000 with labor and stuff. But this will not do a whole house. The other one will do a whole house. Here's these are very common, made by Panasonic. This is a 40 CFM. It's more of a spot HRV. This could satisfy ASHRAE 62.2 by putting it in any part of the house, but it won't bring air into the other rooms. So you have to put one of these in the bedroom, one in the living room, so you can start popping them in all around the house to get better air circulation. Here's a larger system, Vantec. It's 105 CFM. So that's a considerable amount of air to bring around the house. And it has a duct system as well, but just less of them. Here's a little small wall mount. These are new, coming to the country, 71. So pay attention to the CFM. 71 CFM, 22, 40, 105. So the CFM is important because the CFM is in relationship to how much fresh air is in the house, and that's in relationship to how many occupants. So you really need to think about your occupancy loads before you start popping these mini HRVs into the building. But these are choices, they're economical choices to simply ventilate a few rooms, right? And a couple of these, pretty cheap, and you can ventilate a room. They're not as efficient. This one's only 66% efficient. This one is up to 90% efficient. I don't really believe that, but this one is 86% efficient. This one's 79% efficient. The big one here, this is about, I think they're 85, 90% efficient. Testing for air leakage. Okay, now we're jumping to another part of the story. The best time to test for air leakage, the last time to test is just before insulation and drywall. That means rough in, plumbing's in, electrical is in, windows, doors, the exterior siding. It's better if it's not on, but siding can be on. The walls are open and you test for leaking. Plumbing and venting and wiring is done, as I mentioned. No siding, no building papers. All doors and windows are installed, and the wind, I take that back. You can test in a 15-mile-an-hour wind. It just can skew your numbers a little. You can test in a 20-mile-an-hour wind, but your numbers, the windier it gets, the more skewed your numbers get. And if you're shooting for really accurate, stable leakage numbers, fine-tuned numbers, then you have to just, when it gets too windy, you have to walk away and come back another day. The setup. So here's the setup. You're in a building. You're going to test it for leakage. It can be chaotic leakage when it's happening. There's excitement in the air. The blower door is running, and you turn it on, and there's air coming in from God knows where, and people are running around. It's a little frantic and chaotic trying to find the leaks. So I suggest you organize it. If you're going to test the building, is divide up the territories in the house, and you need to have enough people. You don't have to. You could test the house with one person, but it's nice to have at least two people for 1,500 square feet. You go over it and say, okay, the blower door is going to be on. You take the left side of the building and down here. I'll take the right side. You do just the floors. I'll go up on the ladder and do the high spots. You rehearse it and go over it, so you're not crisscrossing paths and doing the same work, like two people find the same leak. Waste of time. You can go around marking the leaks with like blue tape or a spray can, whatever you want, or you can stop and fix the leak if it's simple, right? After a while, you'll figure out what to do, and you get better at the time when the blower door is running. So typically, if you start out at 1,000 CFM, the blower door running, with let's say two people in a 1,500 square foot house, depending on the leaks, you start at 10 o'clock in the morning, and by the end of the day with 2 people, you might get that 1,000 CFM down to 300 CFM. That will happen. The longer you spend at it, the more leaks you find, and the lower the CFM numbers get. And finally, you hit a number and you go, okay, that's good. Let's stop. No more. Because after a while, you're looking for gnat holes, looking for tiny little holes. You need to cover all the large openings. And if you use tape on plastic, they can easily blow off. So you have to keep checking your covered items with tape and plastic. They can blow off. Make sure the P-traps are full. My first mistake. If it's a new P-trap, the plumbers don't leave water in it, and air will leak right out of that plumbing vent. So here's the ways to test. Hand feel, that's kind of what I do the most. When the blower door is running, if you have negative pressure, typically I test with negative pressure. So I'm sucking in air from the outside, and from the inside, I can feel air whooshing in through an outlet, let's say. Now, if this outlet is leaking the size of a marble, you could mass it, you could really feel it. If it's leaking the size of an eraser head, you can feel it with your hand. If you're not sure, if you just slightly dampen your hand, you can really feel the air coming out because of the condensation, because of the evaporation on your hand. Hand is a really good way to quickly go around and feel for leaks. And it feels kind of visceral. It feels like you're part of the building with a wetted hand looking for leaks. A pencil smoker, these are little smoke sticks, really. They burn for like an hour, and you put it near a leak and it'll either suck in or blow out. These are little handheld miniature theatrical smokers that have a plume of smoke to come up. Here's a handheld miniature smoker. I'm outside the building. The building is pressurized, and a friend, Andy Wall here, is blowing smoke directly up to a potentially leaky spot. I'm outside and I'm saying, yeah, I can see the smoke coming out. Another way to test is infrared. You need a bit of temperature differentiation between inside and outside. But with infrared, you can see cold air coming in. Here is a building pressurized. This is that large 4-story building in San Francisco. We smoked the entire building, which was absolutely insane. It was amazing smoke in the building. And then the crew was outside running around, pressurized the building full of smoke. And here you can see smoke coming out from underneath these doors, right? Now, these doors were very expensive European doors, guaranteed to not leak. And they were leaking. Of course, the rep came back and fixed them. But here's the smoke coming out of the building, pressurized. Here is my favorite. This is my favorite way to test a building. This is a cat toy, superfine down feathers. If you put this near a leak, any leak, this is what happens. That thing will pick up a tiny, tiny hole that's leaking. I'll do it again. So I have large things made of these down feathers, baby feathers, and I go around the house, and it's fabulous for finding leaks. Oops, that's the thing again. So I had this slide on the early beginning of the part 1. I'm showing it again to emphasize this slide here, which I did not show in the first one. So let's go back and review this. So a hole in the building, hot and cold, wet, anything can go through a hole, and it can go through in either direction. Air, hot air, and with the air can be heat or cold, wet or dry, humid. Air will move through these holes faster than any other building part. And here's something to kind of illustrate that. Oh, we're almost at closing time. Is that it? Let me see how much we got left. Oh yeah, we're going to make it. This is good. This is the last slide. So what we're looking at here is this sheet here is a 4x8, 5/8 piece of drywall, and this is one down here. And the test conditions are identical. It's in Quebec, Canada. This is from buildingscience.com, and both these sheets are identical. The indoor-outdoor conditions are identical. Indoors, the thermostat is set at 70 degrees. And outdoors, the relative humidity is average of 40% relative humidity. Dryish, you know. In the course of 1 year, vapor can diffuse through a sheet of drywall. In 1 year and one heating season in Quebec, about a third of a quart of water can diffuse. That's molecules, water molecules, going through drywall into the room if they're driven so. This is assuming that the outside is drier than the inside. I'm sorry, the outside is damper than the inside. Moisture is going to move from outside to inside. In one heating season, a third of a quart of water will diffuse through that sheet. You put a 1-inch hole in that sheet and 30 quarts of water will move through it. That's like a big picture story about a hole. So back to here, a hole is not just a hole because stuff moves through it faster than any other building part. And what moves through it is outdoor air, outdoor pollutants, on crawl space air, outdoor pollutant, attic pollutants move through these holes really fast. And we're worried about mold. A lot of times in air sealing, you're worried about mold and condensation. Well, guess what? If you make a hole in a building, you can let in a massive amount of vapor and moisture into the building to add to your mold collections. So I think we're close to being done. Products used in the show. These are a lot of the stuff, all of the stuff I'm pretty sure that was used in it. These are something when I kept talking about elastomerics, these are all roof coatings. These are all elastomerics that you can just put on a brush and use that as your topping on top of foam. And that is the end. And I made it just in time, right, Ian? Exactly on time. That's impressive.
Yeah, that was great. I invite Alejandra to take the stage for some few closing notes.
Okay.
Hi, everybody. Thank you. Thank you for joining for this class. I just wanted to have a quick reminder with everybody about our building performance training offering from the Tri-County REN. Once again, this is through County 3C REN. It's funded by a ratepayer fund. So this is monies that we're bringing here back locally. So open to any suggestions about any classes that you think maybe we should be offering, any instructors that we can, bring to our territory, via Zoom, or once we get to do in-person training, we can certainly figure something out. So once again, just check our website for any upcoming events, and we're open to any further suggestions. If you can please answer the poll that will be launching soon, and then that way we can we can track your feedback about these classes. If you register for AIA credits, we will reach back to you and provide that certificate and all the information to you. And once again, we will take any feedback that you have from us. So thank you. And before you log out, just fill out the poll for us.